Fusion 360 not only utilizes the standard core features found in most parametric CAD software, like SolidWorks, it offers much more flexible tools that help make the modeling experience more intuitive. Let's take a look at some conventional CAD tools, including sketch-driven features and applied features, and how they can alter the model geometry. When I open the initial design, you can see a number of sketches that will be used to create the housing cover features. Before I dive into creating the part, I want to show you where to access the design tools. In the toolbar at the top, you can see the Create and Modify flyout menus. These two menus distinguish features that are either sketch-based or geometry-dependent. They contain some of the most frequently used CAD tools, such as the Extrude and Revolve tools found in the Create menu, and the Fillet, Chamfer, and Shell tools found in the Modify menu. To make the design process simpler, I'll hide most of the sketches. First, I'd like to show you how to specify feature parameters using a Revolve as the first feature. I'll select Revolve from the Create menu. Notice the feature dialog box appears on the right where I can specify all of the parameters. Creating a Revolve feature is just the same as traditional CAD software. First, I pick the profile to revolve, then select an axis of revolution. A preview of the feature appears, and I could continue adjusting the parameters in the dialog box. These look good for now, so I'll click the OK button to complete the feature. The timeline at the bottom captures features as they're created. Just like all other parametrically based CAD software, features are added in sequence and can be reordered, suppressed, and unsuppressed. And the timeline can be rolled back to any point in the design history. When the Revolve was created, the sketch profile was automatically hidden. I'll turn on the next sketch profile to work on the next feature. Next, I want to show you how to create features using multiple sketch profiles. The bottom flange will be created from this sketch using the Extrude tool, which I'll select from the Create menu. In order to create a single circular flange without the hole, I need to select all of the profiles in the sketch. This functionality of selecting individual profiles is incredibly powerful. It gives you greater control over how the sketch is used to create the feature. I want this sketch to extrude upward 10 millimeters, and I'll create this extrude as a new body. Normally, this feature would be joined with the Revolve feature. However, I'm creating this as a separate body to help demonstrate some other features later on in the design. I want to take a moment to talk about operation types. Features have the ability to join geometry, cut geometry, create an intersection between geometry, create new bodies, as well as create new components. This makes Fusion 360's features much more flexible than previous CAD software, allowing for Boolean operations, like adding and subtracting, to be used in the same feature. When I click OK, the new body is added to the Bodies folder in the browser. The next step is to add two fillets to the edges of this face. I'll enable the tool, select the edges, and give them a radius of 5 millimeters. Now that I've selected the edges, what if I want to change them? Fusion 360 allows you to toggle between viewing the preview of the feature and the original geometry selection. Simply hold down the Control key or the Command key on a Mac. This brings up the selection geometry, which I can deselect by clicking any of the edges. When I release the key, the preview updates on the part. I'll hit the Enter key, and the fillets are added. Fusion 360 makes adding features extremely flexible by allowing a feature to be added to multiple bodies. I want to add a fillet feature as well as a shell feature to both the main body and the flange at the bottom. First, I'll create the fillet. I'll select this top edge and give it a radius of 2 millimeters. Now, When I try to select the other edge on the flange, the edge won't highlight. To select it, I need to hold down the Control key on my keyboard to select geometry on other bodies. Now I've successfully added the fillets to both bodies. Now I'll activate the Shell tool from the Modify Flyout menu and choose the bottom circular face of the main body. To select the bottom face of the flange, I'll hold the Control key once again, and then I can select the other face to be shelled. I'll set the thickness to 5 mm and hit Enter. One of the most flexible tools available in Fusion 360 is the Press-Pull tool. This tool modifies existing geometry depending on the selection. For example, if I select this top face, I can pull it upward or downward into the part. I'll pull it upward 7.5 mm and hit Enter. To re-enable the tool, I'll use the upward gesture, and this time I'll select one of the larger fillets. When I drag the arrow, both of the fillets change radius since they are created using the same feature. I'll set this fillet to have a radius of 12.5 mm. Notice in the timeline that the fillet feature has an icon above it. This indicates that another feature is being adjusted while using the Press-Pull tool. I'll click OK to finish modifying the fillet. Now, I'll skip ahead to demonstrate creating features with geometry-dependent end conditions. The sketch shown here will be used to create 3 extrusions with geometry-dependent end conditions. For the first extrude, I'll select all of the profiles in the sketch. To extrude these profiles up to the other contour, I'll change the operation type to Join, and in the Extents dropdown, I'll select the option 2. Now the option Match Shape appears in the dialog box, and when I enable it, I can choose a face in the model to match the contour. I'll select the large upper fillet, and the extrusion matches the outer contour of the part. I also want to highlight that this feature joined the 2 bodies. Because the feature extended into both bodies and was set to join, it combined them into a single body. I'll create a second extrude from the same sketch. I'll select the 4 circular profiles. Make sure to choose the options Join and 2, and match the shape of the inner fillet on the inside of the part. I'll create one more extrude that will cut a hole into the part. I'll choose the 2 circular profiles for the hole, set the options to Cut and 2, and match the shape of the other inner fillet. At this point, I'll skip ahead to a more finished version of the part, which includes some ribs and holes patterned around the outside of the part. To wrap up adding features, I want to show you one of the most convenient features in Fusion 360, adding threads to cylindrical faces. To add threads to this inner cylindrical face, I can activate the Thread feature from the Create Flyout menu. Notice in the dialog box that many of the thread settings are set to Automatic, which will populate once a cylindrical face is selected. When I choose this face, a graphical representation of the threads appears, and the thread specifications populate. In the dialog box, there is an option to make the threads modeled, and when I check it, the threads are physically modeled. Any of these settings can be changed, such as the diameter size, and both the threads and cylinder size adjust accordingly. With all of the features added to the model, I want to demonstrate the flexibility of editing features earlier in the timeline. Because Fusion 360's timeline can be edited at any point in time, such as making a change to this fillet feature, models can be quickly modified. Many of Fusion 360's features do not have extensive downstream effects like other CAD software, making it much easier to make changes to your models. There are many other features that I could walk you through. The workflows of the features used here give you a great foundation for building your models. These tools will help take your designs to a whole new level, especially when working with multi-component designs. No matter how complex the design, Fusion 360 makes sure you can add the necessary features and make modifications anywhere in the model.